Video conferencing. It's a standing joke, right? You just can't go ahead and have a video conference meeting. You always need IT on standby. Well, this can't go on. For over 100 years now, the worldwide telephone network has grown, and even with explosive growth, it's fantastically complex, yet fantastically reliable. And it's based on the simple principle of keeping the dumb devices as dumb as possible and the servers as smart as possible. This diagram represents home landlines, mobile phones, your office PBX and handsets, or even a satellite phone. The interop level on this design lies up there above the servers. In other words, each server will talk to another server out up that level there. The devices don't talk directly to each other. Now, what went wrong with video conferencing then? Well, this approach means that every device ever made has to be able to connect to every device ever made, which means there's a lot of intelligence in each device to be able to do that. Of course, it can also do it using different protocols. Who should care? The big problem, of course, is that means that the device itself is an interop point. It needs to be maintained in order to give it its best chance of being able to work with any other device, old and new and future. This is a bad design. Now drill down into one of those nodes and you may have a typical H323 or SIP on-premise deployment that looks something like this. Servers on the left-hand side provide services such as multi-point, gatekeepers, registrars, directories, and so on and so forth. On the right-hand side we've got various room systems, software, etc. And then of course there's going to be some method of being able to securely get to and from the internet to make calls to other organizations. So the bad news is that there's a lot of interop work going on here. Every one of those servers needs to interop with each other server as well as the devices that are connecting and using the services. And the responsibility for that is yours. Yours, the IT manager, that is, or the IT department. There's software maintenance to go on in each and every device, and that's required because, of course, the fact is that bugs arise and security holes arise and new products are developed which can do clever new things, and so that means that every other device out there needs to be made aware of these new services and features even if they can't handle them, just to be able to maintain a call with them. So the really bad news is that if your VC deployment looks like this, well, I'm really sorry, but it's obsolete. It's either obsolete now or very soon will be. You should consider it as being obsolete now. So let's just have a recap. Here's the bad model with interop points all over the place, your responsibility, flat, meshed, and no hierarchy. Conversely, the simple dumb terminals, smart servers concept that's worked so well for the telephone system is good. And so why don't we just use it? So taking that step one further, then we move those smart servers into the cloud. By into the cloud, I mean, of course, moving it into somebody else's data center, ideally with them owning it, and most importantly with them being the ones responsible for interop. In other words, somebody else's problem. In doing so, the service is shared amongst many people, which brings the cost dramatically down, as well as, of course, the reliability goes dramatically up because it's in everybody's interest that the services are really well maintained. So you still have hardware endpoints and you still have software endpoints. These could typically be proprietary devices. Don't be frightened of that word, it's very common. It just means that those devices are designed to speak specifically to the servers they're designed to work with. Your mobile phone, your home telephone are good examples of that, and your office desk phone is an even better example of that. So the hardware endpoints and the software endpoints make calls to each other, and the calls are routed via the smart servers in the cloud. Nothing particularly drastic there. The cloud then has the duty of routing those calls and, if necessary, transcoding them. Where does transcoding come in? Who cares? Well, if you need to talk to other systems out there in the world, you need to be able to transcode or translate those calls from the proprietary system into more more recognized ones such as 8323, SIP. PSTN just means telephone calls. Link is the other name for Skype for business, and that basically is the largest, probably the largest proprietary network of communication tools out there. So that's the next big component that everybody wants to connect to. And WebRTC is kind of here, kind of coming, but you need to be able to make calls to it and receive calls from it. That's the job of the cloud and the cloud provider. Now, when you have a cloud model, you also get some inherent features of that. Typically they would be directories, because as you sign up for the service, so you get added to the directories for your organization. Firewall traversal and security are inherent because the way the system works of devices or applications making secure connections to the servers in the cloud, much like your bank transactions today. And finally, central management means that your IT administrator or whoever the administrator is can add users and make moves and changes in the cloud. Doesn't have to worry about any servers to do this, it's just another web portal. Additionally, of course, there's going to be some optional services that you can choose to buy into. Services such as recording and streaming. You may want to record interviews, for example, or team meetings for people that couldn't make it. So that's a typical add-on option that you may wish to purchase from either your cloud provider or from another provider, probably in the cloud, I would suggest. Conferencing, again, is a great example of this. Now, every provider of a cloud service will try to make it attractive for you to use their conferencing services. So look at what they do to do that. And finally, you may want to include some traditional legacy products that you may already own and hook those into the network that you're choosing to work with. Those could include, of course, link deployments. Why not? Now, so far I haven't put a brand anywhere near this design concept. Today you can probably get 2 or 3 names to drop in there, but this presentation was made with one in mind, and that is StarLeaf. StarLeaf have a nice set of endpoint products, and this is one of the things that sets them aside from many other cloud providers out there. They've got a lovely touch interface there on the left hand side, support 1 or 2 screen setups, support a variety of camera choices from webcam through to a high-end Sony SRG camera. Microphones are fairly obvious, and finally they all connect into an interface unit or codec. The user interface is universally connected. In other words, it's the same whether you have a hardware room system, a tablet-based, Mac-based, or even phone-based system. They're all got the same user interface, so there's no retraining or required at all. Before I move on, having mentioned StarLeaf, I just need to pay thanks to the person from who I stole this presentation, Mark Richer from StarLeaf, whose good work I've completely plagiarized, so thank you very much, Mark. And finally, at last, video conferencing has started to become reliable, just like the phone system. It just works. Thank you very much.